Hello friends, I hope all of you are doing well. Let us continue with our topic on where we finished off last class. So last class we were discussing about limits. So today let's just continue with that particular topic further again. So what I've done is I've just written down some of the fundamental theorems on limits. You may kindly write down the theorems that I've written it down. You can just pause the video and just write it down. So here plus or minus, it means simply it holds for plus as well as subtraction also, constant, product and quotient, provided that the denominator is 0. Alright, so along with that there are some basic theorems also, which I would like to give you some more important theorems. Let's say theorem 1, that will be limiting value of x power n minus a power n divided by x minus a would be n into a power n minus 1. Of course, where a should be greater than 0, positive values, as x tends to a. The next theorem that would be also important would be, of course, limiting value of, these are all theorems. As per the reduced syllabus, some of the theorems may not be used, but there is no harm in knowing, isn't it? Knowledge, the more we gain, the better for us every time. As x tends to 0, a power x minus 1 by x would be equal to log of a. Theorem 4, you might need all of these theorems anytime, anywhere when you do mathematics. So as x tends to 0, 1 plus x whole power 1 by x would be the exponential e. And then of course x tends to 0, x tends to 0, x tends to 0. There's one more theorem. Of course, I'll just write it down here. That would be theorem number 5. That will be about logarithm. That is limiting value as x tends to 0, log of 1 plus x whole divided by x would be equal to 1. So these are some basic important theorems which you will need. So you can kindly note it down. Alright, so without further ado, let's just start with the exercise. So we will continue today with, we'll start off, I'll try to do this in 2 sections, in 2 videos. So first up, we'll just solve some of the exercises, random questions, that is exercise. Let's begin with exercise 13.1. So evaluate the following limits. So let's start with a simple question, that is limiting value of the function x plus 3 as x tends to 3. Now, there's just basically one working principle, that's one working rule, that is, as I said earlier in the previous class, as long as you're not getting 0 by 0, which is meaningless, you can continue. You can just remove the limits or substitute the value of the limit here. So mathematically we are going to be calculating here. So it's quite simple. Compared to the description or compared to the introduction, this is mathematically, when we solve, it's of course much easier. So now here I can clearly see that I'm not getting 0 by 0, absolutely not. So I can just put in the value of x, and then we can have the approximate value where the function would be approaching towards as x tends to 3. So that will be simply 3 plus 3. So that means limits gone. Okay, you just substitute the value of x tends to 3. So that means this function as x tends more and more approaches 3, this function will tend towards 6. That's a simple question. And similarly, the next question also, that is limiting value of x as x tends to pi, x minus 22 by 7. That's it, isn't it? As x tends to pi, x minus 22 by 7. So here also I'm not getting 0 by 0. So, alright. So these are simple things, 22 by 7. Your only question is, am I getting 0 by 0? If not, substitute, not define 0, not a big problem there. Another question will be limiting value as x tends to 4. Limiting value as x tends to 4 for the function, that would be 4x plus 3. 4x plus 3 divided by x minus 2. So here also we can see given x minus 4, so I'm not getting 0, I'm not getting 0, so I can just substitute 4 plus 3 and divided by 4 minus 2. So that will be 16, 17, 18, 19 divided by 2. That's as simple as that. So let's continue with, I think it's quite simple, isn't it? No, not a big problem. Don't worry, we can easily solve it. So not a big problem, absolutely not. Number 5, that will be limiting value as x tends to minus 1 for the function x power 10. X power 10 plus x power 5 plus 1, x power 10 plus x power 5 plus 1, all divided by x minus 1. So if I put x minus 1, definitely I'm not getting 0 by 0, absolutely not. So I can just substitute the value, minus 1 whole power 10, minus 1 whole power 5 plus 1, all divided by minus 1 minus 1. So for values whose power or exponent is even, that's going to be positive value. For odd, it is going to be negative, minus, so plus 1, minus 2, 1 cancel, so we have minus 1 by 2. Alright, now let's move on to a more interesting question, that is question number 6. Let's move on to a more interesting question, that is question number 6. That is limiting value of the function x plus 1 whole power 5 minus 1 all divided by x as x tends to 0. Now you see here, if I substitute x equal to 0 directly like the other question, 0 plus 1, 1 minus 1 by 0. What am I having? 0 by 0. So now I cannot do that. Okay, now I cannot do that. So I have to find out other ways to solve. Simplify. Here, this basic formula we will be needing, that limit of as x tends to a, x power n minus a power n. Remember the theorem that I gave you just a few moments ago? That is n into a power n minus 1. So I believe that you have it in your notebook, the formulas, theorems that I just gave. We are going to use that. Now, but to apply that basic formula, what happens is the x tends to a. So it's still not in the proper form. Now what I'll do is I'll do a little bit of substitution, that is, let x plus 1 be equal to y. So now let's see what happens. So now we are changing the variable, okay, so I'm not going to write anything, but let's see what happens here. Y power 5 minus 1. Right. And what will happen to x then? As x, if x plus 1 is substituted as y, what will be the value of y? And it also implies that x will be equal to y minus 1. That means x also can be written as y minus 1. So now you can see that it's almost similar. X power n minus 1. 1 can be written as 1 power 5. X minus 1. The only thing is now this has not changed. But this is also easily possible because you see, as x tends to 0, what will happen to the value of y? See, the value of y is x plus 1, substitution. Now as x tends to 0, as x approaches nearer and nearer to 0, it almost disappears. So y will approach 1. So as x tends to 0, definitely y will approach 1. Because of the substitution, so y tends to 1. Now you see, limiting value of the function x power n minus a power n x minus a. So what is the, so in that case it's going to be n. What is the value of n here? 5 into a. What is the value of a here? 1 1 1 whole power 5 minus 1. So 1 power anything is just 1, so I'm just going to write down the answer directly, 5. So I hope that you've understood. That's fine, right? Once again, that is limiting this formula, x power n minus a power n x minus a, x tends to a, will be equal to n into a power n minus 1. So what I did is, without substitution we can do, of course. So x plus 1 I substitute as y, so in that case y power 5 minus 1. 1 can bring us y, 1 power 5. The value of x with the substitution, x will be y minus 1. Fine, no problem. Now as x tends to 0, what happens to y? As x tends to 0, it almost disappears, so y tends towards 1. So y tends to 1, so y tends to 1. So you can see here a, not a big problem. N is 5, so it's going to be n into a power n minus 1. That's 5. Alright? Okay. Let's move on to some other question again. Let's move on to question number 7. Let's move on to question number 7. That is limiting value as x tends to 2 of the function 3x squared minus x minus 10 all divided by x squared minus 4. Now you check. Now you check. If I put x equal to 2, would I be getting 0 by 0? If I put x equal to 2, would I be getting 0 by 0? Definitely yes, because 2 square is 4, 0. 3 2s are 6. 6 minus 6. 2 2s are 4, 3 4s are 12. 12 minus 2, 10. 10 minus 10, 0. So here also I'll be getting 0 by 0. So that means I have to first simplify this. So now let's see how we can simplify this. By factorization, of course. That is by splitting the middle term. 6x minus 5x minus 10. I hope you are familiar with the splitting the middle term concept, because 3 tens are 30, right? So 3 tens are 30 and 6 5s are 30, minus 6 plus 5 minus 1. Not a big problem there. So limiting value as x tends to 2, I can take 3 common. So that's x minus 2. From here 5 I can take common, x minus 2. All divided by a square minus b square. So that's x plus 2, x minus 2. So limit for x tends to 2, x minus 2, 3x plus 5, x plus 2, x minus 2. So x minus 2, x minus 2. So I'll just write here. That's limiting value. X tends to 2. We have 3x plus 5. X plus 2. So now I'm sure that I'm not going to be getting 0 by 0, so I'll substitute in the value of the limit. I can easily get the solution. So that's 3 into 2 plus 5. So that's what I mean. Once you know that you're not getting 0 by 0, now you can just take care of the limit. You can just let it go. So 3 2s are 6 plus 5 plus 2 2s are 4. So what do we have here? We have the value 11 by 4. Is that alright? That was a simple question, just based on simplifying. Again, first see to it. Are you getting 0 by 0? If yes, you have to simplify. If not, alright, not a big problem. Chalo. You can just put in the value. Or, in other words, remove the limit. Anyway, that's all right. That's all done. Let's go to question number 10. What do we have here? Question number 10. And it's limiting value z power 1 by 3 minus 1 by z power 1 by 6 minus 1 by 6. Okay, 1 by 6 minus 1. That tends to 1. So here also I'll give you the hint here. Which formula are we going to apply here? Here also I will be applying the formula of limiting value x power n minus a power n, x minus a as x tends to a, and into a power n minus 1. So can you guess what we have to do here? It's very simple. Just convert that in that particular form, that is z tends to 1, z power 1 by 3 minus 1. So what I'm going to do is, if I can, minus 1. If I can just multiply and divide by z minus 1. Z power 1 by 6 minus 1. So that's almost done, isn't it? Right. But the only problem we see, this is already done. That means limiting value as, but anyway, I'll not do it now. Z tends to 1. So it's a little bit more arrangement that I'm going to do. That is into 1 divided by z power x 1 by 6 by 1. This I'll be bringing it down to the denominator. That is z minus 1. So I guess so far that's alright, isn't it? Now in the fundamental theorem of limits that I gave you today, just few moments earlier, that is in short, limiting value whatever be that extends to a u by v or f of x by g of x is also limiting value of u divided by, in short only I'm writing, and you can check the theorem that I gave you today earlier, limiting value. What I'll do now is I'll use that theorem, I'll use that concept. I'm going to remove this. So that means now what I can do is limit of function of quotient, that is 1 by 3 minus 1. 1 I can write as 1 by 3, no? Z minus 1 as z tends to 1 into, so this limit I can 1 for this also, right? For the quotients also. So 1 by limit of z tends to 1, z power 1 by 6 minus 1 power 1 by 6 by z minus 1. I hope that's clear. Right, limit, again limit of a quotient of two functions is also equal to the quotient of the limit of the functions. Something like we can just separate them, distribute. Okay, distributive. So now that's just for the formula. So what is the formula for this? N into a power n minus 1. So that's n into, what is a here? A, 1. A power n minus 1 whole divided by 1 by 6 into again a 1 by 6 minus 1. 1 power anything is always 1. So let's not calculate there. Okay, so like 1 by 3, 1 by 6. So 1 by 3 into 6 by 1. So that's going to be, of course, 2. Alright? Okay. So that is done. Of course, if you are slightly confused with this, see what I said was 1 power anything was 1, like for example, you see 1 power 1 by 3 minus 1. So that's 1, 3, 1 minus 3. Isn't it? Yeah. So 1 minus 2 by 3. So that's again 1 by 1 power 2 by 3. So 1 power anything is positive, 1 only. So that's always 1. So 1 power anything is always 1 only. Okay? Alright, let's move on to some other question again. Which question shall we do? Alright, let's try to do number 12. That's going to be limiting value of the function x tends to minus 2 1 by x plus 1 by 2 whole divided by x plus 2. So here also if you put x equal to minus 2, definitely we are getting a negative value. 0 by 0. So I will have to first solve. So maybe the numerator, I'll just take the LCM, 2x, so that's x plus 2. Simple question, x plus 2. So limiting value is x tends to minus 2. X plus 2 divided by 2x into 1 by, of course, x plus 2. So that's also done. So that's going to be limiting value x tends to minus 2. 1 by 2x. So now I can just substitute 1 by minus 2 into 2. That's 1 by minus 1 by 4. Simple as that. Alright? Okay. So you can see the problems are not very difficult, isn't it? Alright, let's move on to another question that is maybe, okay, 15. Value as x tends to pi. Sine of pi minus x divided by pi into, again, pi minus x. We can use a substitution method, we will use that, but before that let me just take this value of pi constant out. That's limit x tends to pi, because pi is a known value, so it's going to be a constant for all of us. Pi minus x. Now it's slightly not possible because of course, yes, I forgot to give you some of the theorems on trigonometric functions also. So maybe you can just note down the theorems on trigonometric functions. That would be limiting value as sine x by x as x tends to 0, that would be 1. Limiting value of sine x by x as x tends to 0, of course, would be 1. Alright, it does hold for tan x also. Okay, it holds for tan x also. Another one would be limit as x tends to 0, 1 minus cos x by x is equal to 0. And even for tan x, limit as x tends to 0, tan x by x, of course, would be 1. So this theorem we will be needing. So you can kindly note down this 1, 2, 3 theorems also. So here in this question, we will be using this particular theorem. Now for that, x tends to 0, as we can see there, x tends to 0. So for that, it's x tends to pi, it's not 0. So what I'll do is, maybe I'll make a small substitution. I'll just do it here, that substitution. So let pi minus x is equal to y. So what happens here? 1 by pi limit of sine y by y. That's fine, not a big problem. Let's see what happens here with the substitution. As x tends to pi, what will happen to y? As x tends to pi, that means as x gets nearer and nearer to pi, y will be becoming pi minus almost close to pi. That means almost the same value. So that will always be 0, isn't it? Pi minus x. Now what is x? X is approaching almost very close to pi. So pi minus approximately equal to pi, because x is approaching pi, so it's like pi minus pi will also tend, in that case, y value is also almost becoming 0 only. So now we can use the perfect formula, that is 1 by pi into 1, because that formula as I gave you, x or y doesn't matter. So it's sine of y divided by y, as y tends to 0, it's 1, so the value will be 1 by pi. Alright? Okay, so let's move on to which question then, in that case. Okay, let's do question number 17. It's limit as x tends to 0 cos 2x minus 1 divided by cos x minus 1. Alright, now here we are going to need a trigonometric formula, that is, I'll give you here, you may have studied. So cos 2x is 2 cos square x minus 1. So I'll be using that formula here. So 2 cos square x minus 1, because minus 1 is already there. I'm just substituting the value for cos 2x. Cos 2x from trigonometry, we have 2 cos square x minus 1. Denominator part, let it be cos x minus 1. So I'll just continue here. That's going to be limiting value as x tends to 0, 2 cos square x minus 2 by cos x minus 1. Fine. So that's going to be limit as x tends to 0, 2 common. So that will be 2 cos square x minus 1 cos x minus 1. So that will be, okay, 2 I'm just taking out, constant. So there is one in the fundamental theorem, I've already given it to you. So that will also be constant. Now, cos square x minus 1, you can write, but this is going to be much better, because 1, of course, I'll write 1 square, no problem. So I'll just apply the formula of a square minus b square. So 11th standard, basically we would expect you to know the basic algebraic identities. So a square minus b square, what was the identity? A plus b into a minus b. So that will give me a plus b into a minus b divided by cos x minus 1. So you just remove that. So that's going to be twice of limit x tends to 0 cos x plus 1. So now I'm not getting 0 by 0, so I'll just substitute the value 2. That's going to be cos x tends to 0. So cos 0 plus 1. So what is the value of cos 0? The value of cos 0 is 1, isn't it? So that's like 2 into 1 plus 1. So that's going to be 2 into 2, 5. Not a big problem. The value is going to be 2 into 2. That's going to be 4. Okay, one last problem that we can do. You can check out question number 20. You can check out question number 20. In the meantime, let me get a chalk. Alright. Okay, what do we have there? Question number 20. X tends to 0. Sine of ax plus bx. Ax plus sine bx. It's also mentioned that a plus b are not equal to 0. Okay, fine. Now to solve this, what I will do is I will divide every term, both the numerator and the denominator. Okay, looks a bit congested. I will divide the denominator as well as the numerator by ax. Sir, why ax? That's up to you. You can divide it by bx also. Okay, you can divide it by bx on both the numerator and denominator also. That's up to you. I just think that this might be a much more easier approach, so that's why I'm just dividing it by ax. You can do it by bx also, because I think that here I might just get 1, here also you might just get 1. So sine of ax by ax. I'll write some more steps. That is x cancels. I have b by a. Divided by, this is 1 plus sine of bx by. Okay, no problem. I'll just write some more steps. Now maybe I'll just start, separating them. Okay. Alright, so I think I better start from here. So, okay, quotient rule again. So, let's give a limit x tends to 0, sine of ax whole divided by ax plus b by a. Let's do it part by part. Divided by limit x tends to 0, 1 plus sine of bx by ax. So now here, what I'll be doing here, see, almost there, because sine ax by ax, as we know, I gave you right, sine x by x as x tends to 0. What is it? 1. Of course, it's not exactly x here, but don't worry, we will manage. B by a. Now here to be, for the, of course, at least the angle is same here, as you can clearly see, at least the angle is same. But here even the angle is not same, but instead of a, if I have b, no problem, then bx by bx, isn't it? But this cannot happen all of a sudden, isn't it? It just cannot come all of a sudden. So a, I will just take it aside, and then I'll just multiply and divide by b. No problem, isn't it? Right, again, because b I can just cancel, and then finally I again get ax back to square 1. So just to match, I will multiply and divide by b, and a, for the time being, you go there. Alright, you stay there because I need b, that's why. Okay, so after that, now let's check out here. Sine of ax by ax. Now you see, as we've already done, as x tends to 0, what will happen to ax? Ax, of course, will also tend to 0 because it's a product. So as x tends to 0, a into 0, approximately 0, will also tend to 0. So ax tends to 0 plus b by a. Because there is no variable here, so limiting as x tends to 0 will not have any effect in the value of a constant b by a. No matter what happens to x, b by a will remain as b by a because the variable is independent of the variable there, divided by same 1. So 1 for this will not have any effect because as x tends to 0, 1 will remain 1 only, no variable connected to it. Here, of course, limiting value sin bx by bx. So even bx as x tends to 0, even bx will tend to 0. b by a is a constant. So I will be just taking aside this b by a outside of the limit. I don't need it within the limit because the limit for the variable x will not really affect the values of b and a. So this is 1 plus b by a. Now we're using that formula. This is also 1 plus b by a. b by a into 1, that's again b by a. So now same values, 1 by 1. So our value is 1. So that's how actually you match the theorems, the fundamental theorems, and then you simplify problems based on limits. So these are not very difficult problems, not very difficult problems at all. So I hope that I believe that I could be of some help to you. Maybe in the next edition, again, we will do problems on limits on the second part of the exercise. That's about whether to check whether the limit exists or not, right hand limits, left hand limits, and also definitely if you have liked this video, please do like, share, and then of course please do subscribe if you still haven't subscribed, because I promised you I will be finishing up the whole syllabus, the whole course within this year. Alright, so but you have to encourage, I need your support for that. So anyway, till then, I'll see you in the next video very soon in a matter of 1 or 2 days. So till then, bye bye and study well. Take care.